Let me share my screen for a little bit. I am at a lovely page that many of you have seen me go to. This is a page called about:blank, and you can go here in Chrome. And this is a page that is full of nothingness. And that's nice because I'm going to open up the Chrome console. That is View, Developer, JavaScript console. Depending on your operating system, you'll have a different keyboard shortcut. I'm on a Mac, so here's how I open that up. And here's what we'll do here. Question, are we focusing on OOP in JavaScript? No, instead of object orientation, we're going to focus a little bit more on functional programming, which is another style of writing code, where instead of using some of the traditional tools in object orientation, like objects and classes and instances and inheritance, instead we're going to lean on using functions to organize our code and such. So we're going to be doing things in a little bit more of a functional pattern, and closures are a very common idea in functional programming. So we're not going to get way too into the depths of that or in the math of it yet, but we'll start with some important ideas like closure. Before we talk about closure, I want to define something called a higher order function. For those of you that were fortunate or unfortunate and attended our lecture on callbacks, which is another tricky topic, we also defined higher order functions as a function that accepts another function. If you've ever used functions like array.map, array.map is a function that accepts another function as an argument. Map is a higher order function. It's higher in the order of execution. What does that mean? Map is going to get called first before this anonymous function gets called. Higher order functions are a mathematical term and have many different definitions or requirements. In order for something to be a higher order function, it must accept another function. But a higher order function can also return a function. So another classification of higher order functions are functions that return other functions. The hardest part about this is going to be the why. So I'm going to start with the what so that you can see the syntax and understand the idea, and then I promise we'll get to the why. Because as you start seeing things like call later with parentheses and parentheses, you might be wondering, why would I ever do this? Promise I'll get to the why. Let's knock out the what first. When we talked about callbacks, and we talked about the value of callbacks, we talked about higher order functions, and we leaned on this first definition for what a higher order function is. Today, we're going to talk about this second piece, different kinds of higher order functions. And this is a function that returns a function. In JavaScript, I'm going to make a function called outer. You can return whatever you want. You can return the string hi. You can return an array of 1, 2, 3. You can also return a function. This function can be anonymous with no name, or you can optionally give it a name. It's a good programming practice when possible to name your functions, because when you're debugging and you want to know which function is getting you in trouble, it's nice to have a name to identify that function instead of anonymous, 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 anonymous. You don't have to name it. This is syntactically valid, but I'd encourage you for good programming practice to name it. And inside of this function, you can do whatever you want. I'm going to return hello. This is not a very helpful function. This is not a very useful function. Let's just get our syntax down. This right here is not closure. Closure is not a function that returns a function. That's a higher order function. Closure is this phenomena. It's this really cool thing that can happen. We'll talk about what that thing is in a bit. But right now, let's just get some syntax. Outer is a function that, when invoked, will return a function definition to us. It will return the definition of the inner function. I have two options syntactically. One is I can just take this function that I get back and call it immediately. This first set of parentheses calls outer. This second set of parentheses calls inner. And that'll work just fine for me. And this will return the string hello. Another option that I have, which is a bit more common, is to store the result of the outer function in a variable. We'll call this invoke later. If I look at invoke later, it is exactly the same thing here. It's the definition of the inner function, which I can call over and over again. If you're looking at this and you're like, why in God's earth would I ever do something like this? This makes no sense to put 4 open and close parentheses after a variable. We'll get there. There's some really interesting use cases for this, but we got to just get this syntax down. A higher order function is a function that can accept another function as an argument. It's also a function that can return another function. When you create a function like this that returns another function, you invoke it. And when you invoke it, you get back this entire function definition. If you want to call it right away, you want to call outer and then immediately call what you get back, this is syntactically valid. Bit less common. What is more commonly done is call that outer function, store the result that you get back, the definition of the inner function, in a variable. And then take that variable, which is a function, and call it whenever you want, however you want. Questions on our syntax here. The best way to do this is to go to the Chrome console, go to Replit, go to wherever you're writing JavaScript and just type this out. It's not particularly thrilling, but you got to make sure you get this syntax down before you start doing all of the fancy things that closures can do. Because the good news is, if you have this syntax down, closure is just one little concept on top of this idea. So any questions on the syntax that we're looking at here? I know some of you have seen this before, some of you have not, but I want to just check in. Any questions in chat, feel free to throw them in. I just want to make sure we're feeling okay about the syntax that we have. You could use arrow functions if you want. You can write this in different ways, but I like just using the function keyword. I like giving functions names. That's all I got here. Is there a significance to the undefined value that we get right here? This is what the console gives me as the returned value or output. When you define a function, this is what the console gives you back. When you define a variable like this, this is what the console gives you back. So it's nothing of value for me right now. This is just what the expression in JavaScript returns to us for this line. But there's nothing we're doing with this undefined value that we're getting. It's a good question. All right. Now that we have an idea of the syntax behind higher order functions that accept a function and return a function, I want to talk about what actually happens when JavaScript sees this return keyword. When JavaScript sees the return keyword, it returns a value to us, and any variables inside are cleared from memory. What does that mean? I'll make a function called greet. And inside here, I'll make a first name of Ellie. I'll make a last name of Shopik. I will be proper and add my semicolons. And I'm going to return just a simple string here that says, hello, first name and last name. When I invoke this greet function, I get back, hello, Ellie Shopik. This is template strings or string template literals. This is how we can evaluate variables in a string instead of using the plus operator and worrying about spacing and so on. After this function runs, and it returns this string to me. These variables, first name and last name, they are cleared from memory. This is a process called garbage collection. There is a tool behind the scenes in JavaScript that says, anybody need this first name variable? Anybody need this last name variable? If so, no. Great. When you declare variables in a function, those variables are scoped or only accessible inside of that function. So if I look at first name right now, it doesn't exist. If I look at last name, it does not exist. That's how functions work in JavaScript. It'd be very silly to still allocate memory for this thing because I don't need it anymore. It'd be very silly to allocate memory for this because I don't need it anymore. With that in mind, I want to pose a challenge to you all. Let's all imagine that we work at NASA and we are writing the code to launch a rocket. And we need some kind of variable or a count. And we need a way to decrement the count by 1. And we don't want anyone to mess with it. It's going to be our goal here. A couple questions here. What is a callback function? How is it different? A callback function is a function that is passed to another function. In this case, when you save the return in a variable, does the memory still clear or wait till you call the second function? It depends on how you're handling that. So Peter, I'll get to that in a little bit more detail. It's a good, you're hinting at something nicely, but I'll get to it in this next example. If you ever want to clear your console, you can press Command K or Control K, I think, if you're on a PC. Or you can click on this button right here. And that will also tell you the keyboard shortcuts. So a couple options. I want some kind of variable for a count, and I want a way to decrement the count by 1. I don't want to necessarily do a for loop because I don't want to do it all at once. I want control over when the count goes down. So how can I do this? Well, I could start by just making a count, set that to 10, and say count minus equals 1. And look at that. The count's going down. I can control the count. This feels good. The problem is anybody, anywhere in this code base can say, oh, actually, bam, launch the rocket. Now, all of a sudden, I'm at 0. Someone can say, actually, you know what? Slow it down. Anybody can change this variable. This is the global scope. This is the downside of the global scope when you don't want people messing with your variables. So how do we create scope or privacy? Ray says, declare it within a function. Put the counter in the function, and every time the function's called, it will decrement. Let's go. Excellent. Let's go bring back our little comment here for inspiration. I'll make a function called counter. Inside here, I'll make a count. Maybe we'll start that at 10. And then I will do count minus equals 1. And then I will return the count. So I'm going to declare a count. I'm going to decrement it. And then I'm going to return it. When I call this function, we're in business. We're decrementing. When I call this function again, yikes. Each time I call this function, I make a brand new count that starts at 10, and then I decrement it by 1, and then I return it. So every time I call this function, I'm just stalling at 10 and going to 9, and 10 and going to 9, 10 going to 9. This is the challenge of making things too private. So we've gone from the global scope where everyone can change it to the complete other side of things, which is a function where we can change it. Again, I don't want to loop this because I want control over decrementing this whenever I choose. Maybe that's every 1 second or 2 seconds, or when someone calls a function, I do it. So I could do it all in a loop and immediately do it at once, but let's imagine I wanted to choose when this count goes down, or when someone clicks a button, make the count go down, or every 1 to 5 milliseconds, make the count go down. I need more control than a loop. I can't really do this with much conditional logic here because it's either in the public scope with this count variable, or it's in this function scope where there's not much I can do here. If you'd like to try to solve this in a different way, I welcome you to write some code to do it. But herein lies the challenge. There's a variable that I want to make, that I want to be able to change, but I don't want everyone to be able to mess with it. I want this count variable encapsulated. I want it closed over. But I don't want it to be redeclared every time I call the function. Because every time I redeclare it, I get in trouble. I'm not going to use a callback function here. Because if I use a callback function, then I'm going to either redeclare that every time. I have to use a slightly different pattern. Can't use const because you can't redeclare or reinitialize variables with const. Hopefully you all came here because the answer is closure. So I'm glad we have all these ideas, but the answer is closure here. And I love that it's like loop, condition, if statement. Come on, trust me. I promise the answer is closure, and that's why we have closure. The answer also could be using a class or object orientation or somewhat. So if you say make a private variable in a class or make an instance variable, yes, we have ways of doing it that way. Make a read-only variable. Yes, that is the object-oriented way. But the good news is we have a solution. And the solution to do that is to create the notion. JavaScript does not have this natively. Many other programming languages have this out of the box. The idea of a truly private variable, or the idea of a protected variable that can only be modified in certain situations by certain things. JavaScript, aside from the object-oriented world, does not have direct privacy. So we are going to use functions to do that work for us. And we are going to make use of a phenomena, of this amazing ability that JavaScript has that not all programming languages have. This amazing ability that JavaScript has to remember variables from outer functions that have returned. If you remember, when JavaScript returns, it clears this stuff from memory. It does not remember anything. What I'm going to show you is this amazing ability where JavaScript can instead say, when I return something, don't actually clear that from memory. Hold on to it. Remember it, because I might need it later. That special ability, that phenomena, is what closure is. Let me show you that with an example. I'm going to make a function called outer. And inside here, I'm going to make a variable called first name. I'm going to make a variable called last name. I'm going to make a variable called middle name. So you can all really get to know me. I'll declare these using const because I don't want anybody reassigning or redeclaring. It seems like a reasonable approach. And I'm going to return a function here. I'm going to call that inner. And inside of this function, I'm going to return the string, hello, first name, middle name. Instead of immediately invoking the inner function, I'm going to store that in a variable. And I'm just going to call that invoke inner later. Invoke is another word for calling or executing a function. If I look at invoke inner later right now, it is a function that uses first name and middle name. But those variables, first name and middle name, those are long gone. This function has returned. How is it possible that this function still has the ability to remember first name and middle name? How is that possible? We just said that when JavaScript returns, it clears those things from memory. Well, JavaScript is pretty smart. When JavaScript sees that you return a function, it doesn't just clear everything else from memory. It does a quick pass and it says, anything inside here that I need to remember from outside before I return and clear everything? Oh yeah, first name and middle name. Cool. I'll hold on to those for you in what is called a closure scope. And when I call this function, it does what I expect. I'm going to go ahead and use the Chrome console and put a debugger statement here, because I'd like to show you something. Depending on, Peter, does it save it on the call stack or the heap? It depends on the type of data that it is. If it's a primitive type, it can store it on the stack. If it's a reference type, it has to store it in the heap, because you can't really store reference types on the heap, or sorry, on the stack. If you go ahead and call the outer function, and let's go ahead and follow our same pattern. We're going to call this invoke later, and we'll run this function. I'd like you to put in chat the number of variables that I have access to right now. The good news is the answer is either 1, 2, or 3. So I've given you a 33.3% chance. Feel free to throw it in chat for how many variables do I have access to right now? Because this is a really good learning point for closure. All right, I'll give you some even better news. The answer is 2 or 3. So now you have a 50% chance. So I'm seeing a lot of 2s and a lot of 3s, which is good. So we're on the right track here. But I'm seeing some 2s and I'm seeing some 3s. And that's great. What variables do I absolutely have access to? What variables do I need to have access to? Well, I got to have access to first name because I'm using it in this function. And I got to have access to middle name because I'm using it in this function. But JavaScript is smart. It sees that this inner function is no longer using last name. So it would be very inefficient to remember a variable that does not need to be used. This is called a memory leak. You're allocating memory, but you're not freeing up that memory at any point, or maybe even when it's too late. So I do not have access to last name right now. The answer here is 2. It's not that JavaScript remembers everything. That would just be inefficient. That would be a big waste of memory. All that JavaScript remembers is what it needs. And we can see this in the Chrome DevTools by taking a quick look at the call stack. There's no outer. The call stack is where your functions live when they are invoked. Outer is long gone. Outer has returned. So there's no outer here. But in the inner function, we have a closure scope created from the outer function. This is the phenomena. This is the amazing ability that JavaScript and not all programming languages have to remember variables in outer functions long after they have returned. Closure is the phenomena. Closure is the ability for a compiler, for a programming language, to remember variables from outer functions long after they've returned. So we're not doing anything particularly thrilling with closure right now, but this is what it is. It's the amazing ability. You will hear terms defined as, a inner execution context and lexical scoping and so on. Feel free to look those up and such, but I want to keep this as simple as possible. But at the end of the day, this is simply just variables in inner functions being able to access and remember variables in outer functions long after the outer function has returned. Outer is nowhere to be found right here. A couple questions here. Scott asks, when does the closure expire and release the rest of memory? When it returns. unless of course it returns another function, which then you just have a closure, enclosure, and enclosure. So essentially, once you return something, which in this case, we're returning a string, basically anything that is not another function that uses closure again, JavaScript says, cool, I'm done. I don't need these anymore. JavaScript is only going to hold on to something as long as it needs to. And the second that it does not need it, it will clear it. This is one of the beauties of higher level languages. Whereas if you were doing this in C or in C++, you would have to tell the compiler, now is the moment to free this up. Now is the moment to free this up. So that is the blessing of working with higher level languages. It's got its own trade-offs, but this is where you can lean on compilers to do this work for you. Peter asks, so it remembers only the ones you allocate in the return function and intelligently gets rid of the rest? Yeah, that's the idea. There's no need for JavaScript in the inner function to know my last name. It's not being used. There's no need to allocate memory for it. There's no need to hold on to that memory. So the second that this function returns, the compiler is not just going to say, great, clear it all up. It's going to say, oh, we're returning a function. Hold on. What's inside this function? What do I need to remember? Let me hold on to those, free up everything. Garbage collect the other things that are not necessary to remember. The best way to play around with this stuff, make silly examples like this one. Learning the Chrome dev tools, playing around with the debugger is invaluable. If you're ever going to do any kind of development in JavaScript anywhere, it's a really powerful tool to learn. Works across pretty much any browser. They all have their own version of this idea. But this is where you can really examine what functions are being invoked, what scopes do I have, what do I have access to at this point in time. It's a really awesome tool for that. A couple other questions here. So outer is stored in global memory, correct. The only thing that is in the global scope right now is my outer function. That is correct. And so it does it once and then deletes it. Yes, that is the idea. Yep, exactly the case. This is the big reveal. It's like the big, oh my God, this is closure. So I hope it's not as scary as it seems, because you can make this very academic very quickly, but this is all it is. That's the what. Why would we ever do something like this? Well, what's pretty nice about closure is that we can access variables inside of these inner functions, but only inside of these inner functions. These variables, first name and middle name, now become what we call private variables. Only the inner function has access to them. Because by the time the outer function runs and returns, the only thing that has access to them are these inner functions right here. Ben asks, now, is that the nature of return or the nature of function scope that they get deleted? That's the nature of return. That's what return basically does. So return, you might have learned return of like, oh, it exits you from a function. It does a lot more, under the hood. And when you get your post-bac in computer science or master's in computer science and you build a compiler, you will work with all of those things, but obviously that's very abstracted from you. Return is going to do quite a bit of popping the function off the call stack, allocating or deallocating memory necessary. So it's doing quite a bit for you under the hood there. Really good questions to kind of like dive in and try to peel apart under the hood. And this is why there's so much to learn here. So it's great. If the inner gets deleted, does it need to be named? It doesn't need to be named. And it's not that the inner function really gets deleted, I would say. It gets run once, and then it gets run however many times you store it again. It's just nice to name your functions. And the only reason is, here I just see that this thing is called inner. If I did not name that function, it would work totally fine. It is syntactically valid. The only problem is when things get a little bit harder and I'm debugging, all I see is just anonymous, 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 anonymous. So when you start writing more complex code, you start doing more complex things with recursion or functions that call themselves and functions with inner functions and such, it's just nice to have a name for those functions so you can identify what's the thing that I am calling right now. as opposed to just anonymous, 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 anonymous. That gets really hard when you work with library code or really large applications that are calling 10, 15 or so functions, and you don't really know which one is which. So good rule of thumb, if you can give your functions a name, you should. When you use arrow functions, which is a different way of writing a function, they're always anonymous. And that's just the way they are. This would absolutely work with an arrow function. You just wouldn't be able to name it. So could you syntactically go ahead and return this syntax right here? Yes, this is syntactically valid. Could you go ahead and do, const outer is an arrow function and go ahead and do that? Yes, you could totally do that. Honestly, maybe I'm just old school. Maybe I'm writing JavaScript for too long. I like named functions. I like arrow functions when they have a purpose, when they have a meaning, when I'm using it for the value of the keyword this or a callback function or keeping things short and sweet. I don't really feel like they get a lot of value from doing, this right here or so on. Different style guides, different rules. I'm one JavaScript developer, so I have 6 opinions. It's kind of how it works with this stuff. But yes, this would absolutely work with an arrow function. You just wouldn't get that benefit of naming the function, which, might seem a little low value now, but when you work with really large code bases, it's just nice to know what's calling what. These are really great questions, y'all. Thanks for throwing these in chat. Any other questions before we talk about why we'd actually use this thing? We spent 35 minutes talking about the what, so we should probably spend at least 2 minutes talking about the why. Let's go back to our problem of the counter. We couldn't put it in the global scope because anybody could change it, because anybody can modify it. We couldn't put it in a function because each time that we declare it in the function, we're making a brand new one each time. So what we're going to do is we're going to define it once. And then we're going to return a function. You can call this whatever you'd like. I'm just going to call this inner counter. And inside of this function, I am going to decrement the count, and then I'll return it. Are there fancy one-line ways to do this? Absolutely, but it's not worth it right now. Let's just make sure we know what we're doing. When I go ahead and run this, I now have a function called counter. Counter returns to me a function called inner counter. So I'm going to store that in a variable. I'll call this my first counter. And it is the result of the counter function being invoked. This function, when invoked, returns to me this whole thing. So I look at my first counter. I can see here, this is a function called inner counter. It is decrementing a count and returning that count. But wait a minute. How does this function here know what count was and how to modify it? That function outer that defined it has long returned. How is this possible? Closure, this ability for inner functions to remember variables declared in outer functions long after the outer functions have returned. This count variable is encapsulated. It is protected to only the scope of the inner counter function. When I call inner counter, or when I call my first counter, we're going to take that number 10, we're going to decrement it and return it. Then we're going to take that number 10, which was decremented once here, and we're going to decrement it again. If I go ahead and say, ooh, ha, 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 now the count is this right here, and I call the function, doesn't matter. The way that JavaScript finds variables is it starts where it was called and works its way out to the global scope. So it's going to find the count inside of here way before this global one. No one can modify this outside of calling my first counter again. And better yet, if I make a variable called my second counter, which is the result of the counter function, and I call my second counter, it makes a brand new count variable. So it's not like this count is shared between every single time that I call the function. Each time that I execute this function, I get a new count. So these are not going to mess with each other. If I call my first counter over and over and over and over, and I look at my second counter, still 8. These are two totally separate things. These are two totally separate places in memory. These are two, to use an object-oriented term, instances of data. Question here, it remembers inner counter because it is the return value of counter. Yes, it remembers that because I'm storing it in a variable. So that's the reason why it holds that in memory, because I'm making a variable, which is the return value here. So we're allocating a little memory for the returned value of this function. And then through closure, counter has long returned, but this inner variable is used and is remembered. This allows us to create the notion of privacy, encapsulation, and so on. If you assign second counter to be my first counter and then invoke my second counter, so if I say my first counter is now equal to my second counter, if I go ahead and call my first counter right now, it is going to be a reference to my second counter. If I call my second counter, it is going to be the same thing. So yes, this would essentially replace my first counter with a reference to my second counter. Why you would write code like this, I don't know, but it's a great question if you want to kind of mess with references. So if you're feeling masochistic and you want to hurt someone who's going to have to read your code, you could totally do this, but it's an excellent educational piece. So yes, you're spot on that it would reference the same function. I mean, to be very pedantic, it wouldn't reference the same call stack. There's just one call stack where all your functions live. It would reference the same place in memory that that function lives and where its variables live. So it's basically just saying, hey, instead of being at a different place, just go point to that thing. That's what we're doing here. It's always nice when people ask questions, can you nest closures? Because then they have an idea of how closures are working. So yes, you could absolutely nest closures. And in very complex functional programs, you will see that idea. Give me a function that returns a function to me, or if all of the arguments have been passed in, give me the returned value. This is a concept in functional programming called currying. Beyond the scope of what we need to do here, but currying is a technique where you take a function and you say, call it as many times as you need. But once you've passed in all the arguments that it requires, give me back that return value. So maybe you have a function called add that takes in 2 numbers. If you call add with nothing, just give me back that function over and over again. If you call add with 1 argument, great. Give me back that function with that 1 argument remembered, and then call it as many times as you need. I'll show you a little example of that with something more gentler called partial application. That's a very important piece in functional programming. Where else can closure be helpful here? Well, Justin asked, so in this example, you could create a function to keep track of a different player's score, and you can assign each player's different variable in your inner function. Yeah, very much so. That's exactly that idea. The object-oriented approach is to make a class that has some data. The functional approach is make functions that return other functions. So I might have something like a function for calculate taxes. It takes in some kind of rate. And here, I'm going to do something like base rate is going to be, for some reason, let's imagine that everything starts with a 2% tax rate times, 1 plus the rate. We're doing some kind of basic tax calculation. We can return a function which accepts a parameter. And we're going to return the base rate times the amount. So what are we doing here? We're going to write a function called calculate taxes. And I'm going to do something like California taxes. Calculate taxes, and I'm going to pass in a rate of 0.5, so 5%. When I look at CA taxes, I now pass in an amount. But through closure, this base rate is remembered for me. What's nice about this is I can say, hey, New York taxes, oh, that's a 7%. Minnesota taxes, that's 2%. And later on in my code, someone can say, oh, I need to calculate how much that amount was in California taxes. Great. I need to calculate how much that was in New York taxes. Great. What we've done here is we've passed in one argument. And by the time that New York taxes and Minnesota taxes and so on is called, the person calling this function just needs to know the amount. This is a very important idea in functional programming, because what you do is you call a function and you pass in some arguments. I don't know what the amount is that you're going to get taxed. I just know that the sales tax in California is 7%. So what I'm going to do in my code is I'm going to say, hey, let's calculate taxes for California at 7%. And then I'm going to say, hey, Grace, later on in the code, when you calculate all the payments, just call California taxes. Grace is going to say, well, what's the tax rate in California? Don't worry about it. I set that for you. This is a principle in object orientation very commonly called abstraction. Don't worry about the implementation details, just use what you're given. This is the functional approach to that. I know what the New York tax rate is, so I'm going to call the function, and then I'm going to hand it to Nikki. And Nikki is going to calculate some input from users and then figure out the taxes, but Nikki never needs to know what the tax rate is in New York. We're separating our responsibilities, we're separating our duties, we're separating our concerns. I've abstracted that away from Nikki so that Nikki can focus on collecting, money from our customers or whatever it may be. These kinds of patterns allow you to separate the responsibility. What's nice about this is we don't have to make a function like this, calc taxes, that takes in some kind of rate and some kind of amount. These will do the same thing. This is our function through closure. This is our function without. If I call calc taxes, there are two things that I need to know right now. I need to know what the rate is, and I need to know what the amount is. And every single time that I call this function, I can keep passing in the rate and keep passing in the rate and remember what the rate is and remember what the rate is. It's a little too much responsibility for one person. What I could do instead is say, hey, I'll give you the first piece. We'll call this California taxes. And now when I call this function, all I need to pass in is the amount. And whoever calls this function, they don't have to worry what that percentage was. Also, I know nothing about like sales tax and rates. So if you're like, well, actually it's 7.5, you're probably right. So just work with me in this example here. So if I look at chat and I see that, I don't want to see that. Is this an example of an interface? Not exactly. An interface is a little bit different. An interface is a contract, usually dealing with the types or functionality that your classes have. Functional programming doesn't really have the idea of an interface. In true functional languages, you do have types themselves, but an interface is usually, here is what every instance of the class looks like. Here are all the methods that the class has. Here are all the return types they have. So not exactly here, the similar kind of thing. Can you talk a little bit about what's happening when you use function arguments? Is it effectively like an undefined variable? Yes, that's exactly what it is. Function arguments are variables that are created when the function is run, and you assign a value to those variables when you call it. When I pass in 0.07, I am assigning a value to the rate variable. Right now, it's undefined. When I invoke it, I assign a variable to it. So one of the nice things that Clojure can do for us, and this is where, it's helpful for the counter example, but I encourage you to make that counter example for yourself and then think about little cases where is there something where I'm just, every time I call this function, I'm still passing this in again and this in again. And it's very likely that the second argument is going to change. But if I'm calculating taxes for the same place, it's very unlikely that the first argument changes. And that will work. But if we're really thinking about writing some quality code where I don't want to worry about that, or I accidentally change this and now everything breaks, or I don't really know what this means, so I just pass in this number. This is where functional programming purists will say it's a cleaner design to have functions that return functions, and you just take what you need at that moment. So these both do the same thing for us. We're just tackling this problem in slightly different ways. Calc taxes just gives me a number. Calculate taxes gives me a function. And through Clojure, I have remembered part of what I need here. From a performance perspective, how good is Clojure compared to writing everything over and over? Premature optimization is the root of all evil. The likely performance bug in your application is definitely not because of a Clojure that you've written. However, there are frameworks like Angular 1 in particular, that had lots of performance issues because it didn't deallocate things properly. So it definitely is an issue with library code or when you're dealing with things at quite a bit of scale. But in terms of writing everything over and over again, it's not going to make much of a difference, because at the end of the day, you're essentially doing the same thing. This is simply just holding on to a primitive value. So the amount of memory it's taking is negligible, whereas this right here is creating a primitive and then clearing it from memory. The performance impact is negligible here. Why is California taxes declared as a const? Because I don't want to reassign it and I don't want to redeclare it. So it's better off as a const. I don't want anybody giving this a new value. Could declare it using let. Doesn't make much of a difference here, but I want to be consistent there. Could you eliminate the const base rate? Yeah, you totally could. You could go ahead and do something like 1.02 times 1 plus rate. I just think for readability, it's nice to have a variable here that does that. But yes, you could absolutely condense that all to one line. But we're doing closures and this, and I didn't want to hurt your brains too much. So yeah, Robert, you totally could. That's totally valid. Other questions here? You've got the foundation. You've got the idea. You've got the purpose. You now have this tool in your tool belt. And in reality, I have the good news and the bad news. The good news is you really don't find yourself writing closures too often. The bad news is you really don't find yourself writing closures too often. But next time you have a JavaScript interview, someone's going to ask you about it. So there's a very high correlation of ask me an interview to don't use in real world. And I'm not poo-pooing closures by any means. When you learn about functional programming languages, you work with Erlang, Haskell, Scheme, Lisp, you use closures everywhere. When you don't have loops, when you don't have objects in your language, you have to use these kind of ideas. JavaScript is kind of a mix of functional and object-oriented. Doesn't really lean in one direction or the other. So you can use either one. But there are many, many libraries, many internal tools when you learn about frameworks like React that make heavy use of closures. So it is an important idea to know because you will find yourself using tools that use it under the hood. But unless you are explicitly writing your code in a very functional stance or purpose or design, you won't really find yourself writing closures too much. It's not a bad thing by any means. There are times that you can use it. Similar to ideas like recursion, even callback functions. In my day-to-day programming, I'm not using a ton of recursion. My day-to-day programming, I'm not writing a ton of closures in JavaScript. Are there certain problems that lend themselves well to recursion? Absolutely. Are there certain problems that lend themselves well to closures? Absolutely. But that is the minority of most programming problems that you're going to solve. But it's a really interesting idea. It's a fun thing to play around with. And if you ever do learn functional languages or want to learn functional languages or have learned functional languages, you're going to see these ideas everywhere. JavaScript happens to be kind of a playground for all the above. Questions before we wrap up? Any additional things I want to throw in chat? Feel free to, as I do my little exit spiel. Thank you all so much. This is your time. This is lunch for many. This is times all across the world. So appreciate you giving me 55 minutes or so of your attention, of your time. It means a lot. I love to teach this stuff and it's super fun, but it's really awesome when there's a engaged audience and people who are really kind of into it. So thank you all so much for that. Again, we are a 16-week full-time coding bootcamp. We focus a lot on small class sizes, experienced instructors. So we do lots of code reviews and real-world projects and things that many other places can't do. So if you are looking for a bootcamp, if you signed up for Rithm already, awesome, you can cover your ears. But if not, take a look at our program. We're a little bit different. We do things a little bit differently, and we care a ton about what we do. We will be doing a bunch of meetups like these over the next couple months. We are kind of, doing some repeats of other ones and experimenting with new ones. If there are things that you'd like to learn about, definitely do let us know. Reach out to us. If there are people you think could benefit from this as well, invite them in, welcome them in. We're all really into building community, especially when you're learning these tougher concepts that are not always the most fun and friendly. So definitely want to just invite you all to keep coming back, keep learning. Don't be a stranger with us and help out as much as you possibly can. Peter asked the question, are there any keywords that create the private variable situation that a closure gives for you? And the answer is yes, but you got to do it in a class. So if I make a person and I do something like first name is Ellie right here, this is actually how you can create a private variable in JavaScript in a class. This is new as of 2022 or 2023. But if I make a new person right now and I do p.firstname, can't access that, p.firstname, this will allow me to do that in the Chrome console because the Chrome console is being very helpful. But if I actually look at this variable here, it will not display in code. So it's unfortunate the Chrome console kind of helps me with that. So it doesn't actually give me this as a helpful piece. I think syntactically, if I go ahead and do this in the constructor, see if Chrome has changed its ways around this. Let's see, person here. Yeah, it's going to be declared a closing class. Okay. Constructor. Yeah, I don't think this is going to let me do that directly. Yeah, it's not going to let me do that syntactically right off the bat. But if you want to take a quick look at private variables, MDN, you will see here's the basic syntax for doing that. The Chrome console, unfortunately, is just a little bit too friendly with letting you do things and play around with things. But to give you just a basic idea of how you can do that, you can create a private field. You can assign it a value. So let's see if the Chrome DevTools let me play with this example. I'll just show you this last piece. All right, let's go make a new instance of this. We'll say new. That's with private field. If I take a look at data.private field or data.private field, it's still going to give it to me, which is unfortunate. This is the Chrome console just trying to help you with private fields. But if you take a look at that, this right here is technically not accessible. So if you ran this with Node or in a JavaScript environment that wasn't as friendly as the Chrome DevTools, you would actually get an error with that. So The answer is yes. Unfortunately, the Chrome DevTools don't give us that nice luxury. Any other questions before we wrap up here? All right, y'all. Thanks so much as always. Hope to see you again on Zoom real soon. Thanks for listening in. I hope this was valuable, and have a wonderful, wonderful week and weekend, everyone. Take care.